So my topic is stranger danger topic, securing cloud native applications. So I want to show you how you as a developer who is developing business applications can secure your code, but without being a security expert, right? So I show it to you from a developer perspective, but then also from a attacker's perspective. So I just make myself a bit smaller here. So a bit of background. So I'm not an ethical hacker or a pen tester, right? I have a generic software engineering background. So I'm now in pre-sales at Sneak. Before I ran my own software development company for around 15 years in Hamburg and also in China for around 8 years. I then moved into consulting and pre-sales. But background-wise, I'm a generic software engineer by heart, I would say, right? So this is a bit of my background, and I'm just interested in AppSec and also open source. So that's how it all fits together. And I 1 or 2 years ago, I initiated a meetup in Stuttgart and Frankfurt. So I wanted to follow and do the same with the DevSecOps, DevSecOn now as well. So this is a bit of background about myself. And I like motorcycling, as you can see. So now, what is the problem we have as a software developer? So in the pre-cloud era, let's say 10 years back, right? Life was easy for me as a developer, right? I was handling my application code, obviously the code I write, which is my own intellectual property. And then I include open source libraries, and that was it, right? Life was easy. I hand over my artifacts, give it to the operations team, like the sysadmin or ops, whatever you want to call it, and then they would deploy it on the server, right? So it can be maybe virtualized, it could be on bare metal, but they took care of the network, the server, the VMs, everything. So I only had to worry about my own code, maybe security issues or flaws in my code, and known vulnerabilities in open source libraries. Now, when we move to the cloud, we distribute our applications in containers. We run these containers in a, let's say, Kubernetes cluster, for example. So all of this now becomes also part of my application because the developer in the end is also configuring the container, maybe the Docker file, the Kubernetes infrastructure as code as well, or what we call infrastructure as code. So what can go wrong, right? What can possibly go wrong? So we can see this here in the middle. It's issues in my own code, issues or vulnerabilities in the open source dependencies that I'm relying on. We can have bad configurations. For example, I copy paste something from Stack Overflow because I'm lazy and I take default settings from a Docker file, or maybe unpatched operating systems, base images that have issues, and maybe I leave ports open that shouldn't be open, right? So I have a lot more to cover than in the pre-cloud era as a developer. So now we say it's now DevOps, right? It's a shared responsibility by developers and operations together. So looking at the software supply chain of the code base, obviously I have my own code, right? This is my intellectual property. I write the code. I'm aware of what I'm writing. This is very obvious what and how I should secure it in a way, and based on my experience as a software engineer. Now, underneath, I show this iceberg here. Underneath the water surface, we have open source code. Now, in modern applications, we can say 80 to 90% of the code base is open source code, right? So that means that only 10 or 20% of my own code of my application is actually my own code, right? So this is one thing. Then the other, let's say, challenge we have is that open source code is vulnerable, right? There are always security issues. Of course, they get fixed, but there are always new ones coming in newer versions and so on. But the vulnerabilities don't necessarily sit in the direct open source libraries or dependencies. They might be somewhere underneath in indirect dependency, maybe on the second or third or even fourth level, right? So it's hard to detect and be aware of that. This is one thing, open source dependencies that I rely on because I want to develop my application faster. My goal is, of course, I don't want to care about security so much. I want to develop my business application, go to market early and fast, right? So this is my intention as a business application developer. Now I wrap the application in a container because I want to ship it as a container. That's the way to do it these days. It's fast. You can spin up a container or turn it off again. Now these containers, when you create your container, they rely on images and base images, which have hundreds of Linux packages coming pre-installed with it, right? So these system libraries, open source, they are known, they have known vulnerabilities. This is also something you would need to protect in terms of choosing your right base image to use underneath your application. And then infrastructure as code is where you define how and in which way your containers are running in the Kubernetes cluster, right? So there are some research studies also from the NSA who say that the #1 reason or cloud vulnerability is caused by misconfiguration, right? By just leaving default settings to default and so on. So this is a problem. And you can see here, the risk profile is not about my own code or only open source dependencies. It's a bit more if we talk about cloud native applications. So what I want to do is I want to protect everything. I want to protect my own code, like a small percentage where I can use static analysis that understands my code, my algorithm, and so on in a semantic way. But then for the rest, like open source libraries, they are already known, right? There I can rely on what's called a vulnerability database, where we just check, is this library that I'm relying on in this and this version vulnerable against security risks, right? So that's from a software supply chain and what an application is made of today. Now, let's take an example that I will show in real life in a bit. So as I said, let's say 80% of my application is based on open source. So here on the left, I have a Java application. Actually, it's a Spring or Spring Boot application. It's very simple. Let's say it's a to-do list application. It consists of 3 files and around 80 lines of code. And I rely on 7 dependencies here, right? So these dependencies are common Spring framework dependencies, something like data JPA, data REST, HATOAS, JDBC, and so on. So these 7 direct dependencies doesn't sound like a lot, but they bring in 59 transitive dependencies or indirect dependencies, right? So it's like it multiplies up. So in the end, because of that, 80 lines of code are now over 700,000 lines of code if I count all the lines of code in my dependencies that I have here, right? So you can see the risk potential that I have as a developer, what I need to cover in terms of code security, right? So we do have a yearly study on the lower left. You can see there it says STEAK State of Open Source Security Report. This is a yearly report we give out, and we research a few numbers. For example, we can say that open source vulnerabilities increased over the past 3 years by factor 2.5, and then also 78% of vulnerabilities are found in indirect dependencies, which for a developer is hard to find. So in 2017, there was this Equifax issue coming up, or this incident. So they were using Apache Struts, which is a Java framework. It was quite common back then before Spring became more and more popular, especially like 10, 15 years ago, but it's still being used, not as much anymore. However, so Equifax got fined around $700 million because they were exposing over 150 million people's personal information, right? They leaked it because of a vulnerability in this Struts framework, or in particular in a particular library that it was using. So the problem, and this is a good example, that's why I'm showing it. The problem is that you always have to monitor your applications. You always have to know the bill of material in your project, because once an issue or a vulnerability has been found, it's very fast that it's being exploited. So this is the timeline that we see here. The Apache Foundation was notified that there's an issue with Struts, the framework. Okay, they released a patch or fixed the vulnerability. And of course, not everybody using Struts is upgrading right away, maybe not even aware of it. So we can see that once they published the fix, a day later, there were already the first exploits out in the wild, anywhere in the exploit DB on the dark web, and they are being used by hackers, script kiddies, and so on. So the attacks, the number of attacks reached a peak even 2 weeks later. The peak was already reached, but by then Equifax hadn't fixed the issue because they couldn't respond that fast, right? So that's why it's important to be really aware of issues, monitor. Even if you don't touch your code base, maybe it just sits there, but researchers find or attackers find new issues in libraries. You want to be aware of it, and the easiest way to do so is make developers aware of it, as opposed to just the security department who has to create a report, send it over back to the developers. Or even better, if you can, why not just make a pull request right in the Git repository, right, where you're using Struts. Just say, we are aware of an issue, you should upgrade to a certain version. It can also be automated in a way that you can say, okay, I let some tooling automatically create a fix for this library, or in terms of an upgrade. So I want to show you this in a real life example, because I don't want it to be too theoretical. So I show you this particular example that was the issue with Equifax. It's a remote code execution. So it has a certain CVE number. So CVE stands for common vulnerabilities and exposures. It's a list of publicly disclosed known vulnerabilities, and each of them gets a number assigned. It's always the year and then a running number. So let's go and check out this example. So what I have here, I have a Struts application running, and I have it locally, but I also, to be more realistic, I have put it on Heroku, like a platform as a service, right? So this is now, let's take this Heroku application as an example. So this is my to-do list, very simple, just a few lines of code. But I have all these dependencies I rely on, including the Struts framework. I can do just sign up to my application. It's very simple, so I just sign up with anything. Doesn't really matter what I use here. So as you can see, it's form-based, right? It's this login form. Of course, if I'm smart, I use Auth0, I guess. Anyway, so this is just a simple application. I can create a to-do here. So nothing really exciting, just a plain to-do list. I can create, edit my to-dos, that's it. I can upload files and so on, but this is using Struts. And if I go to my About page, of course, this application now is built for the purpose of demoing, so it's intentionally made vulnerable, right? But I show you here that it's using Struts in a certain version, and this version I know is vulnerable. Now, what happened with Equifax is that they didn't fix or upgrade the version fast enough, and somebody could make use of it and exploit it. So what happened is that to understand the issue or the flaw, when I use Struts and I create an error, or the framework creates an error, it looks something like this, like an error page, like a status problem report, right? So the hack is the following. Now I need my terminal here. So this is my term. This is my local terminal, and I of course have prepared a exploit for this. So here I have what you see now is my application. It also runs on localhost, but what I want to focus now is on my exploits. So I have the page running on Heroku, and I have here an exploit folder. So this is what I want to show right now. And what I have prepared now is a certain header file. Now, what I want to do is, as an attacker, I want to intentionally make the Struts framework throw an error page, because the reason is that Struts tries to give as much as possible information to the user why a problem occurred. So like this, you can see it even spits out the particular line in XML. So Struts is using a specific library, and this library is called OGNL. So where is it? And this library, what it's doing is it's parsing the information about why an error happened, right? So it's trying to how to say evaluate the reason for the problem. So what we're doing now is I want to make a request to my Struts or to the victim's website. I want to intentionally throw the error. So what I'm doing is I prepared a certain header. This header is the content type header, which usually is sent along in a request, in an HTTP request. But here we can say this content type, which can usually be something like multi-part form data or application JSON, for example. But I intentionally make this an invalid content type. And you can see here, I put this in these brackets. Now, because Struts is using this OGNL library, where I always forget the name, is called Object Graph Navigation Language. So what's happening is we're passing a content type, which is illegal, right? And to the vulnerable endpoint. And with this illegal content type, we are going through an exception pass here, right? So this is what we want to achieve. We want OGNL to pass what's in here, and inside these brackets, what we're doing is we're spinning up a process builder, which means this code, what we see here, is being executed, evaluated by OGNL and run. So we can see we try to pass this command like a bin bash here, and then we pass along a command to get more information from the server, which we're actually not supposed to do. So I have this header prepared, and now let me. So what I do now is I take this line, for example, here. Let me take this from Heroku. If you look at this line here, what I'm doing is I'm sending the headers, this content type header. I'm replacing the command that was in there with my own. For example, here I want to say I want to fetch the environment variables. This is what I would type in Linux then to my Heroku application. So I'm sending a wrong header. And because OGNL is evaluating what's in between the brackets, it's running this command, the bin bash, with my env command, which returns the environment variables of the system. So if you look in the response, what we're getting here, we can see here a lot of information about the environment variables on the Heroku instance, right? Now, in this case, it's just about Java home path and a bit of information, but it could be even more like access token or access key or an API key in there if somebody put it there as an environment variable. We also can do other run other commands. For example, let's say what's always interesting to see is like on Linux systems, you're interested in the etc password file, which is containing the users or usernames, right? So this is something you would like to know usually, and we can also check actually under which user we are running. So let me just grab again the right command. So I can do a who am I, for example, to check which user the process is running under. So I get this user something with a number, so we can at least see we're not the root user yet, right? So if I try to get the etc shadow file, which usually contains the hashed passwords of user, I shouldn't be able to do so, or maybe because I'm 1 second. This one over here. So if I try to get the shadow file, I shouldn't be able to do so because I'm not a root user. But if I would be root, I would be getting access to the shadow file. So that was the exploit, right? So they for Equifax, they could get access to the environment, and then they get access into a further another database or file where it contained admin credentials, where they could then access the database that was holding the personal information of the customers. So that was what's happening with Equifax then, and I showed you this application now on Heroku. I had the same application here on my local host, and in this case, I was spinning up this application through Docker, through a Docker command. So what I showed you here before with these exploit commands, I can do the same, but run it against my local host. And what we can see there is that in this case, I would have, 1 second, I would have even access to my shadow file because I'm now running as root because I'm using a misconfigured Docker container based on a misconfigured Docker file. This is the exploit that happened with Equifax, right? So the question is, could I have avoided it as a developer, right? Would I have been made aware of it? So what are the possibilities to do so, right? So, and this is where tools come into play that secure your applications. So this is also what Snyk is doing, for example. So if I have my application here, let's say locally in my folder, this is a Struts application locally now, my source code, I could do something like a Snyk test, and it would do a scan for vulnerabilities against my regarding my dependencies, including the Struts framework. So I can run this. This is now locally, right? If I'm a developer, like a single developer, I can run this locally. And we're now analyzing the dependencies. So in case of Maven or Java, we're checking the POM XML for information about dependencies. And we collect the dependencies and the dependency tree, and then check it against, in this case, it's our vulnerability database to see all the issues we have in the product. So we can see here a list of problems. So it's both license compliance issues about the open source licenses we're using, but it's also about security issues. So if you scroll up a bit, we can see different issues marked either red or yellow. So the red ones meaning that these are high severe issues. So we can see here at the top, we found 52 dependencies, and among those we have 59 issues. And the issue I was referring to regarding Equifax, for example, it's somewhere in here with the remote code execution, right? So these tools tell us also what to do. If I would upgrade my struts framework from this version 2.3.20, which I'm using, to a higher version, which isn't vulnerable anymore, 2.5.26, I can actually get rid of all these issues that I'm having currently in my application. So it's a good practice to use such a tool as a developer locally. It can be like this in the CLI in the terminal. I can also go ahead and use the same in my IDE. So if let's say I am a Java developer, I'm developing the application in IntelliJ. I can also have a plugin, for example, and we are providing one of those where you have the same kind of output or information in here where you would scan your project. You would get the information listed that you have an issue with this struts version, how you can fix it, and then you can go ahead and change the struts version accordingly, right? Now, this is what I can do locally, right? I want to scan my application locally. I want to be aware of it. But now, if you're working in a wider team, you want to have an overview of what's going on overall in maybe your Git repository, or also in your maybe CI/CD pipeline. So this is something where you could use a tool like Snyk. So I will show you what can be done for securing the projects in the first place, also right in the Git repository. So in here, I have my vulnerable projects. The way I would use my Snyk as a vulnerability scanner is that I would connect this with my Git repositories. So I can say, I would like to add into Snyk my projects from, let's say, GitHub. So I have the integration already set up. That's why I see all my projects from Git broken down by organizations. I can select all my repos. I can just select a few. So I'm using just a few ones here, and I can select them and then add them here to Snyk. So what we're then doing is we're basically looking into the repositories for manifest files. So if it's a Java application, it will be a POM XML. If it's let's say a Node application, it will be the package JSON or package.json. And we're looking for the dependencies in the application and building a dependency tree. So if I go into one of the projects over here, let's take this one here. We have run a few tests already. So what we see here is I have a project that is a Node.js project. It has a package JSON. This is where my open source dependencies are referenced. Then I might want to deploy the application as a Docker container on Kubernetes. So that's why I have a Docker file in here. I also have a Kubernetes deployment YAML file over here. And also we are running a static analysis for my own code, which is SAST, static application security testing. For the moment, let's just focus on this package JSON over here, because this is the next vulnerability I want to show you. So I have my project. It's a different one now that I'm going to show. And we get a report of all the issues I have in this project. So this is what we see, a list of all the issues sorted by severity. So how severe is the issue I'm having? Is sorted in descending order by high, medium, low severity. And then also it's giving me a priority score. So this priority score is calculated by us. It ranges from 0 to 1,000, but it's considering taking a few factors into consideration, like the original CVSS score, which is a certain way of scoring vulnerabilities based on various attributes. Also the exploit maturity, which means is for this particular vulnerability an exploit available out in the wild that somebody can just use nothing to develop on his or her own, and how old or how new is this vulnerability. So I get this information. I also get information about my dependencies overall. What are my direct dependencies, but also what are my indirect dependencies, right? So because I might be aware as a developer of my direct dependencies that I have in my Node.js package.json or in my POM XML, but I might not be aware right away about the indirect dependencies, right? So this is important information to give to the developer, but then also important, how do I fix an issue? And the next thing I want to show you is an issue about an ST library, in particular a so-called path traversal, or directory traversal. So this is a library of a node which is doing or delivering static pages. So I want to, or I know that my application is vulnerable to this issue over here, and that's why Snyk found and showed me this issue here in this report. Now, if I want to fix the issue, it's very easy to do. I would see this issue here in my report. I can say, fix this vulnerability, and what we're doing then is that Snyk would automatically create a fix branch on GitHub in my case, and then also create a fix pull request. So this is a list of all my issues. The one I selected is pre-selected over here. I just want to fix for the moment this ST library and say open a fix PR. Now Snyk is communicating with the GitHub API, opening, creating a fix branch, creating the full pull request, and all we're doing is simply fixing the issue by upgrading the ST library from this version to this version, right? So we always try to upgrade or do the smallest step possible, the smallest jump to the next possible version that is not vulnerable with this or for this issue. So we can see here, this is the pull request. What's changed is the package.json and package log. We can see here, it's just an upgrade, a minor upgrade of this library. And this way we have fixed the issue. It's very easy for a developer who is not a security expert to understand and then merge the pull request and fix the issue. Now, if I don't do this, let me actually jump to the application I have prepared. So this one it's also a to-do list application, but it's a bit different. It's now written in Node.js, and of course I can enter my task in here, right? And it's using ST to deliver static pages. So I can enter my task, but then if I go to the about page, this is the static page. It's delivered through the ST library, and now I want to do a directory traversal, which means I want to get out of the folder where the application is running in, or that is provided as a publicly available folder. I want to break out of this folder through a directory traversal. So I want to get out of it on the server side and fetch some information that I'm not supposed to do. So usually what you would think of is a directory traversal. If you're familiar with the command line a bit, you would say, okay, if I have this page, let's say I can just do a ... You know, this is how you can go up a directory and then try to maybe steal certain information from the server, like this, for example, right? If I do this, I'm not successful because the ST library is smart enough to figure out that I'm trying to do a directory traversal. It knows the pattern ... But what I can do is, if I go to my command line, let me go into the right example over here. And I also have my exploits prepared. So what I'm doing is I can URL encode this // and if I do that, let's do a curl, for example, here. This is a curl command. Curl is just for fetching and making a HTTP request. And I'm doing this now, calling this URL of my application and putting this // in here, but URL encoded, which we can see now we are successful because it's listing the folder content of my server. So now I can go ahead and say, okay, if this is running in Docker, why don't I just look for the Docker file? And let me see if this is the wrong path. Let me see something is okay. I think I'm somewhere wrong here. Yeah, so what I was doing is I was fetching now the Docker file. So I was in the wrong hierarchy of the folders, but I'm going one directory up and there's a Docker file, right? Which I'm not supposed to access usually, but now because this ST library has this flaw, I can actually go up by hiding my directory traversal attempt through URL encoding, and let's see the information about the Docker file, which interestingly, we can see that there's no user directive in there, right? So we know this Docker file is running as root. So I can even do a bit more. I can say, now that I know this, I can try to, first of all, fetch the password file, which means the list of users. So in the past, passwords or hash passwords used to be in here, but now they're in the shadow file. But because I am the root user, as we saw from the Docker file, I can also ask for the shadow file, which might contain hash password. It's a bit hard. I mean, you can't really, you have to, unhash or a brute force unhashing the passwords, but there might be useful information in it eventually, or at least already knowing the usernames might already be helpful. But this was an example of directory traversal, and this is just because this one library that I was using, ST library, had an issue, which was in the end easy to fix if I would be made aware of it, right? So looking at the time, I think we're almost at the end. One thing I wanted to mention, like in the previous Struts application, you might ask, okay, how do I know that it's using Struts, right? Because from looking at this from the website or the other website I showed you on Heroku, how do you see that it's using Struts? Obviously, you wouldn't put the information there somewhere on the about page. This is obvious, right? There are ways to find this out. So it's called Google Dorking. So if I want to know what's out there in the wild that's still using Struts, that's still eventually vulnerable, I can go ahead and do this Strut Stalking. So what I'm Google Dorking, what I'm doing is I'm looking for the string that's usually on these error pages. I can see a bit. So these, what you can see there, some from government. If I go there, we know, okay, this website, for example, is using Struts under the hood. It's using this, the development mode is enabled. So these are all potentially vulnerable. So even though Equifax happened like 4 years ago, and Struts isn't that common anymore, it's still an issue, right? So that's what I wanted to show you. So there are tools to mitigate this. There are tools to make developers aware of all the issues you have, be it in a Docker file, be it in your application code, be it also in your own code. Let me go back for 1 minute here into the project. So We need to go into the right. So I showed you a vulnerability or two based on open source dependencies. I also might want to scan my Docker file or Docker image or the underlying base image that I'm using. For example, I was using Node 8 as a base image. I want to know what are the issues of this image. So for example, the one I was using, it has 800 vulnerabilities. It's a lot, right? So we give this information out. We understand that if I would do an upgrade to Node 12, I can lower the issues by 300. If I go with a different tag or different, let's say, flavor, let's say Buster Slim, for example, I can even reduce down to 55. Of course, I have to do my testing whether this base image is suitable for my business case, but still you can see it's quite a lot of risk I take away by just upgrading to this different tag. So also in terms of container, I can do some scanning. I'm aware of which libraries are vulnerable. I can also run similar tests locally in the CLI, for example. So what I showed you, like just one example, because I showed you that this one Docker container was running in as root. There's a tool called Docker, for example. So this one would also check your Docker file, check against best practices, which is also called CIS benchmark, and it would notify you that, for example, your container is running as a root user, which shouldn't be the case. So you can, to summarize, coming to the end, you can mitigate the issues by being, even though being a business application developer, just be aware of security issues or risks. Use tooling, but the tooling, of course, if you want developers to use it, it has to integrate into your IDE or wherever you're working, right? It shouldn't be an additional burden to somebody. It should be integrated right in where I'm working, in the terminal, in the IDE. Let me see if this one is doing anything. Oh, it takes a bit because it might just fetch the, it probably fetches the image. Let me do it over here. But coming to an end, let me open the chat if we have any questions over here. Yeah, it's I'm just reading the comments now. So I think something is slow here on my end. Yeah, I think I have some issues with Docker. So anyway, I will. This is a tool you could use for checking a Docker file locally for CIS benchmarks or best practices. But I will stop now here with my screen share, and then yeah, come. Okay, now it's finished. It's been a while. So you can see here, these are the results. It's warning me that the last user should not be a root, so the container is running as root. It shouldn't be the case, and a few other warnings. If you run such tools, Docker or Snyk, depending on what you want to scan, your own code, Docker file, Kubernetes files, Terraform, for example, right? We also can scan Terraforms. Just use the tool. It's just basic security hygiene. So thank you for listening to my talk. It's quite tight on the time, I know. Also, thank you everyone for joining the meetup. Also, thanks Tobias for being a speaker.